So I think we'll get us started. So Darko was originally supposed to introduce Andrew. And when he was reading his introduction to me, I was like, oh no, Darko, if you heard what Thumper's mother said, you can't do that. He said, well, if you think you can do it better, why don't you do it? And so that's an improbable explanation for what happened this morning. A more likely explanation, the possible explanation, is that Darko is sick, and he asked if I could step in. But I thought that was kind of interesting because one of the things that Andrew studies and has studied early on in his career is how people make distinctions between possible, improbable, impossible explanations for events. And so I thought it'd be an opportune time for me to introduce him. Andrew is a professor of psychology at Occidental College. He got his BA in psychology from Princeton. He went on, got his PhD from Harvard, and that's where I first met him 24 years ago in 2001. So I've known him for quite a long time. And the first interaction or impression I had of Andrew, it was actually going to Susan Carey, his grad advisor, one of my grad advisors, when he first started the program. I was like, why'd you admit him? But it wasn't because I thought there was something wrong with him. I was just genuinely curious, like what went on in her mind. And she said, she said, well, his undergraduate thesis was remarkable, incredibly original. He did something completely independent on our intuitive understanding of evolution and how that can create barriers for people understanding the actual science of evolution and principles of evolution by natural selection, and how their intuitive theories can sort of mess things up in their learning of science. And that he did this fabulous work without much mentorship at all. So he was really independent thesis. And that stood out to me because just by contrast, when I started as her lab manager at that time, she read my thesis and just kind of smirked at me and said, nice try. And so there's a big contrast in her assessment of our works at that time. So Andrew then went on and he's received a number of really exciting awards. So an early career award from NSF, a scholar award from the McDonald Foundation. He's published on vast number of topics in cognitive science. He's a newly elected president for Society for Philosophy and Psychology. His work really cuts across basic cognitive science, conceptual development, philosophy of mind. He's published several books. One of them I'll put a plug in for. I don't get any royalties. Science Blinds, and it's really about how our intuitive theories really can make it difficult for us to learn more formal scientific concepts. But it's something that Steven Pinker writes about. So on the back of his book, you hear Steven Pinker, who we all know, has this tremendous praise about Andrew's how he's able to really develop these original important ideas, highly relevant for science and intellectual life. That's one perspective. I will say that my 14-year-old just said the other night that it's kind of dry. And so I tend to believe the truth lies in the middle of two contrasting views. And so I'd encourage you guys to take a look at this. But Andrew just does really phenomenal work, basically trying to understand how we think and the incommensurability of different kinds of concepts that we have in conceptual change and development, and how that can affect how we can learn in our environment. I wouldn't pigeonhole him as saying he's a developmental psychologist. I think he probably identifies as more of just like a cognitive scientist and just really interested in the core questions of our thought and mental representations and how that changes at all stages of life and affects how we learn and interact with our environment. So pretty sure it's all. I will say one last thing. Well, I'll say this. You think you know someone. I remember this quote from Robert De Niro in Meet the Parents, said, can you ever really trust someone? And the answer, of course, is no. And so I wondered what is lurking in Andrew's demeanor that I just don't know if I can really trust this. And he presents as a really friendly person. If you ever go to a conference, he's always asking really kind and thoughtful questions and deeply intellectual questions, even on topics he doesn't readily study. So I thought there's got to be more to this. And so I've always wondered if he has some secret life where maybe he's a criminal. He's just really good at presenting otherwise. But if you've ever watched those border security shows, you know that you can't come into Canada if you have a criminal record. So I only learned yesterday when I saw him that he actually made it across the border, which means he doesn't have some, shady past that he's been hiding from me all these years. So I now feel a little bit better that I can trust him more. So with that, I'll pass it on to you.
Okay. Thank you for that introduction, Andy. I thought you were going to reveal something that I didn't. Thank you all for coming and for inviting me. I'm going to be talking about cognitive reflection, which is where my research program has focused over the last 5 years or so. So I thought I would start off with a pop quiz. All right, so imagine there's some lake, and in this lake, there is a patch of lily pads. Every day, the patch doubles in size. If it takes 48 days for the patch to cover the entire lake, how long would it take the patch to cover half of the lake? So most typically, people answer 24 days because they just take 48 and divide by 2. But the correct answer is 47 days because of the exponential growth rate of the lilies, which means that the lake had to be half covered one day before it was fully covered. So many of you may recognize that item. It's from a cognitive reflection test. The item was designed to elicit an erroneous intuition that you can flag as wrong and override with a more correct, more analytical response with reflection. So reflection is this process of thinking about one's thinking, and it includes several skills. So error monitoring is involved. You have to ask yourself, does 24 actually answer the problem? It includes inhibition. Should I respond with 24 or should I think about something else? It requires flexibility of thought. What's another way of answering this problem? And it also requires analysis. So if you do decide you need an answer other than 24, what other approach are you going to take, and are you equipped to take that approach? So cognitive reflection was first introduced as a construct with the cognitive reflection test developed by Frederick in 2005. It only has 3 items. The lily pad one is item number 3, where the correct answer is 47 days and the Lua response is 24. The other 2 items you've probably seen before, like the bat and ball problem and the widget problem, they have the same structure. So cognitive reflection turns out to be a powerful predictor of higher order cognition, all kinds of forms of higher order cognition. So adult scores on the CRT predict their normative decision-making abilities, their endorsement of normative thinking dispositions, their understanding of science, their acceptance of science, their rejection of paranormal ideas and superstitious ideology, their ability to engage in causal learning, their ability to detect fake news, how cooperative you are, whether you avoid stereotypes, and many other abilities and skills. But one thing that cognitive reflection has been characterized as, which I think is a limitation, is that it's a kind of style of thinking, or maybe a disposition towards thinking. And so in the adult literature, it tends to be treated as an individual difference variable. You either have it or you don't. But cognitive reflection has to come from somewhere. Where did those differences arise? And how does cognitive reflection as a set of skills actually develop? So I'm going to tell you today about a cognitive reflection test for kids. And I think the study of cognitive reflection is developmentally significant for a number of reasons. So there are methodological reasons. Given that cognitive reflection is easy to measure, you just present some brain teasers that have that intuitive versus analytic structure. And in addition to being easy to measure, it predicts all sorts of important abilities. It's theoretically important because it's a simple domain general test of reasoning that predicts all kinds of domain-specific competencies. So it gives us some insight into the domain general contributions to some domain-specific process. And it's also educationally important because cognitively reflective individuals are less prone to biases and errors, more prone to learning. So if we can foster reflection, that might also foster learning in a variety of contexts. So with a former postdoc, Andrew Young, who's now at Northeastern Illinois University, he and I developed a developmental version of the cognitive reflection test that we call the CRT-D, D for developmental. And the research that I'm going to talk about today has been published in these papers here. All right, so I have 3 main claims that I want to convince you of today. The first is that you can measure cognitive reflection in children, and that it predicts rational thought in children independent of their age and culture. It also predicts domain-specific competencies, a variety, in fact, but I'm going to focus on scientific reasoning in particular. And we've been finding that cognitive reflection is malleable, that if you encourage children to consider the adequacy of an intuitive response, that can improve their scores on the cognitive reflection test, and presumably it would have downstream effects as well. So we'll start with just measuring cognitive reflection in children. All right, so the original CRT with adults is a set of brain teasers, and certainly there are many brain teasers that exist out there for children. We designed our test for elementary school age children, K through 6 or 5 through 12 in age. And in order to present brain teasers to children, they had to have certain kinds of content. So these brain teasers couldn't require math. The original CRT, they're all math problems. And in fact, numeracy is a large contributor to how well you do on the CRT. So instead of math, they had to draw on general semantic knowledge, and also semantic knowledge that's early developing, that even a 5-year-old could be assumed to have. And then the problems can't just be difficult problems, or problems where you either get it right or you just have no response at all. Instead, the problems have to elicit an erroneous intuition that you can then override with reflection, an error that is self-evident upon reflection. All right, so we scoured the internet for good brain teasers, and we also pulled a few brain teasers that were in alternative versions of the cognitive reflection test for adults. So this is one of the ones that came from the internet. What do cows drink? And so you all laughed. So you probably got the tension here between the typical answer milk, because of the semantic association between cows and milk, when in fact they drink water, not the milk they produce. And here's another one. If you're running a race and you pass the person in second place, what place are you in? So this triggers the intuitive response of first, but you haven't passed the person in first place, only the person in second place, so you're now in second. So the final CRT-D has 9 items on it, and they exhibit the kind of structure we were looking for. So in general, the most common response is the intuitive lure response, followed by the correct answer, and the least common kind of responses are just random wrong responses. We did have to throw out items that didn't meet these standards. One of my favorites that we threw out was, what do you put in a toaster? Which triggers the intuitive response, toast, but you're supposed to say bread. But kids don't have toasters these days, and they're not using toasters. So they were saying things like bagels and pizza, and we didn't get the right response distribution. All right, so now that we had this set of items, we had to validate them. Do they measure what we intend them to measure? So the original CRT, it's a measure of reliance on analysis over intuition. And so accordingly, it tracks performance on heuristics and biases tasks. And it also tracks endorsement of normative thinking dispositions, like need for cognition, open-minded thinking. So we developed or found child-friendly versions of heuristics and biases tasks and normative thinking disposition instruments, and administers those to children along with the CRT-D. So our participants in our first study were 96 children between 5 and 12, with a mean age of 8, and they were recruited from public playgrounds and tested on site using iPads. And we also had a comparison group of 100 adults recruited from MTurk. They completed the same tasks, as well as the original CRT and an alternative version of the CRT, meant for adults. Okay, so our rational thinking tasks for the children included a denominator neglect task, where they were asked to choose which bet they would take. One bet gives you 9 chances of winning out of 100. The other bet gives you 1 chance of winning out of 10. And so the correct answer here is the second bet, even though having 1 chance of winning is less than 9 chances of winning. And so if you picked 9, you'd be neglecting the denominator in the situation. We administered a belief bias syllogism task, where we led children through a syllogism like all pigs fly, Wilbur is a pig, therefore Wilbur can fly, and asked them whether that conclusion had to follow. So we had arguments that had unbelievable conclusions that deductively followed from the premises, as well as arguments that had believable conclusions that did not deductively follow from the premises. A base rate sensitivity task where we asked children to decide between two options, one that was backed by statistics and one that was backed by an anecdote, like two choices of roller coaster to go on, and statistically people preferred roller coaster A, but your friend preferred roller coaster B. Which would you go on? And then other side thinking, where we asked them to take a position on whether kids should have cell phones, and then generate reasons against their own position. And we counted up the number of reasons they were able to generate. In terms of normative thinking dispositions, we found a child-friendly version of the need for cognition scale with items such as thinking is fun for me, and I like learning new things. And then we also measured actively open-minded thinking that had items like, it is good to listen to the other side of an argument, and changing your mind is a bad thing. And that one was reverse coded. All right, so first let's just look at how well children of various ages performed on the CRT-D. So we have children between 5 and 12 here on the x-axis. On the y-axis, it's the score from 0 to 9. And you can see as children are getting older, they are increasing their score on the CRT-D, which in and of itself is an interesting finding because the CRT has 3 items and there's not a lot of variability. Most people get none of them correct. But you can see just across the elementary school years, there's a reliable increase in cognitive reflection, at least measured by this test. So the youngest kids are getting between 0 and 2 correct, early elementary schoolers 3 to 4 correct, later elementary schoolers 5 to 6 correct. When you give this test to adults, they tend to get between 7 and 9 correct. But there is substantial variability, and I'll talk about that in a minute. All right, performance on the CRT-D did correlate with performance on the heuristics and biases tasks, almost all of them. And it was strongly correlated with the composite measure of those tasks. And it also correlated with the endorsement of normative thinking dispositions, as well as the composite measure. So we ran regression analyses to see whether these effects were just being driven by age. Is it just the case that older kids are doing better on these tasks, and older kids also happen to do better on the CRT-D? And what we found is that age did correlate with the composite measure of rational thought and the composite measure of normative thinking dispositions. But even when you control for age, performance on the CRT-D continued to explain significant variance in both of those variables. So when we gave adults the CRT-D, we found their performance correlated with performance on the original CRT as developed by Frederick, as well as an alternative version that had more problems and a larger variety of problems. And we found that adult CRT-D performance correlated with a composite measure of their rational thought, though not their normative thinking dispositions. So all in all, the CRT-D predicts rational thought and normative thinking dispositions in elementary schoolers independent of their age. And the CRT-D can be used with adults as well, even though they're at the top of the scale rather than the bottom of the scale, as they tend to be with the CRT. There's variability, and that variability correlates with other measures of CRT that are out there. So in a follow-up study, we were curious whether we had documented something that's specific to Western samples, because Western culture tends to emphasize analytic thought, and the CRT is all about measuring the extent to which you privilege analysis over intuition. So in the study I'll tell you about now, we recruited children from an Eastern culture, China, where that culture tends to emphasize holistic reasoning, which includes things like context, continuity, and similarity. And given that cultural emphasis on holism rather than analysis, it's possible that cognitive reflection might emerge later in those cultures or emerge differently. It would relate to, say, heuristics and biases performance in different ways. So our participants were 111 children recruited from 4 regions in China, also recruited at public playgrounds and tested with an iPad. So the 4 regions were North China, North Central China, Southeastern China, and West Central China. And then we also had 130 Chinese adults that were recruited from a subject pool that was run by the Chinese Academy of Sciences. Here are Chinese translations of 7 out of 9 of our CRT-D items. We had to drop an item that was about Santa Claus because it didn't translate culturally, and also an item where it was the trick was a rhyme with eeny, meeny, miny, mo, and that didn't translate either. But for the remaining 7, we saw the same response structure where the most common response was the intuitive one, followed by correct answers, followed by random responses. So here's the CRT-D scores for the American sample and the Chinese sample across the various ages. And for the American sample, we're looking at the 7 items that are the same as the ones that we translated. And you can see that the relationship is pretty similar, that they're increasing to the same degree with age. The scores are increasing. We saw that the Chinese sample had slightly higher scores than the American sample, but we didn't control for things like socioeconomic status or educational background, so it's hard to know whether that's a meaningful difference. In terms of the predictive power of the CRT-D in the Chinese sample, we saw that it had the same predictive power as it did in the American sample, predicting almost all the measures of rational thought and strongly predicting the composite score, and also predicting the normative thinking dispositions. And then again, if you do regression analyses, controlling for the contribution of age, you find that CRT-D scores still explain rational thought and normative thinking dispositions in this sample. We also did a regression analysis with our 2 samples, the Chinese and the American samples, looking at the contribution of country of origin to see if there was a main effect or it interacted with any of our other variables, and country of origin just had no effect. So we saw in this combined analysis that age mattered, at least for rational thinking. The CRT-D scores mattered, but country of origin on its own didn't explain any variance, and it didn't interact with age or CRT-D scores. With the adults, the CRT-D correlated with the original CRT, and an alternative version also translated into Chinese. And it correlated with the various rational thinking tasks and normative disposition tasks. So the CRT-D predicts rational thought and normative thinking dispositions in China, just as it does in the US. And so cultural preferences or emphasis on holism versus analysis doesn't seem to impact the emergence of cognitive reflection or its relations to other forms of reasoning. All right, so moving to the next part of the talk, where we're going to examine the relationship between cognitive reflection and other kinds of higher order cognition. I want to give you another pop quiz. Okay, so imagine you're standing in an open field and you shoot a bullet horizontally into this field from a gun positioned 5 feet above the ground. A second bullet is dropped from a height of 5 feet at the same moment. Which bullet will hit the ground first? And your answer options are the bullet that was shot, the bullet that was dropped, and both bullets will hit the ground at the same time. So the correct answer is both bullets will hit the ground at the same time, but many people think that the bullet you drop will hit the ground before the bullet that was shot. Because the bullet was shot, people think it's been imparted a force that will keep it aloft for longer. But the moment that the bullets are released from the gun and from the hand, there's only one force acting on them, gravity, and gravity will pull them to the ground at the same rate, albeit very far apart. So that was a problem that was meant to assess your understanding of Newtonian mechanics. And Newtonian mechanics is counterintuitive, even for people who've had college level physics. And part of answering that problem right is that you have to have had instruction in mechanics. So you have to have the requisite knowledge. But that's not the only prerequisite for answering the question right. You have to be able to suppress a conflicting intuition. And in this case, it's the intuition that the shot bullet has been imparted an extra force that keeps it aloft. So in order to reason about counterintuitive scientific ideas, you have to suppress this conflicting intuition in order to engage with the science. And that kind of calculus mirrors the calculus that's measured by the cognitive reflection test, where there's a tension between intuition and analysis. And what we found with adults is that performance on the adult CRT correlates with how well adults reason about counterintuitive scientific ideas across a variety of domains. So the study I'll tell you about is one that we did with children. We wondered if that relationship between cognitive reflection and science understanding emerges from the start when children are first beginning to think reflectively and also first beginning to learn science. Maybe these two competencies are not yet linked. Maybe all that's needed to reason about counterintuitive scientific ideas is some threshold amount of knowledge or experience in the domain. So in the study, we administered the CRT-D to 152 children, recruited from parks with a mean age of 8. And then we also measured their math and science understanding. So we picked vitalist biology as our domain of counterintuitive ideas. That's the idea that what makes something alive is it's a metabolic being. It takes in energy to further its own survival and reproduction. So that would include animals and plants. But intuitively, we think about things being alive in terms of whether they move on their own. So plants are not intuitively something that is alive because they seem stationary. So we presented children with a variety of animals, plants, natural phenomena, and artifacts, some of which were moving, some of which were stationary, and asked them to judge whether each of these things was alive. And then we also presented them with various organs and asked them what they're for. And children got points for knowing the function of the organ, but also being able to relate that function to other internal functions to support life. And we also looked at a counterintuitive idea within math, which is mathematical equivalence, which is the ability to solve problems like this: 1 + 5 = blank + 2. So the correct answer here is 4, but many kids would put 6 in that blank because they view the equal sign as a prompt to put the answer here, and they would just add up 1 + 5 and ignore the +2, not knowing what to do with it. So here we also measured executive function, because we wanted to show that if cognitive reflection does predict science understanding, it's not just because of just general information processing skills, that it's doing something above and beyond the information processing that we know very well through the various forms of executive function. So we measured inhibitory control using the flanker task, where children saw an arrow pointing in one direction or the other, flanked by arrows pointing either in the same direction or in opposite directions. And so when they're in the opposite direction, it's harder to respond correctly. We also measured cognitive flexibility. We used the dimensional change card sort task, where kids saw cards with figures on them that had a color and a shape, and sometimes they had to match the cards by color, sometimes by shape, and which dimension they had to use was cued randomly by the experimenter. We also measured flexibility in a self-directed manner with verbal fluency, where children were asked to name as many animals as they could in a minute or as many foods as they could in a minute. And this is a measure of flexibility because the way you tend to perform this task is by pulling up a subcategory like pets, zoo animals, forest animals. And once you can't think of any more animals within that subcategory, you have to flexibly shift to a new subcategory. And then finally, we measured working memory with a backwards digit span task, where we gave children multi-digit numbers and asked them to repeat them backwards. And if they performed accurately, we increased the size of the number all the way up to 8 digits. And some kids really did get that far. All right, so here we're looking at the contribution of CRT-D scores, along with everything else we measured, to children's composite score on our vitalist biology measures. And you can see that the CRT-D at the top explained more variance than anything else that we measured. So we measured executive function tasks, but we also measured some of the things that I told you about earlier, heuristics and biases tasks, and normative thinking dispositions. And then in the math domain, we found that the CRT-D was a significant predictor, but not the strongest predictor. I think it was the second or third strongest predictor. All right, so we showed that existing differences in children's science understanding are correlated with their cognitive reflection, their scores on the CRT-D. But what about their propensity to learn science? Is it the case that a child who is more cognitively reflective on average would also be more responsive to instruction about counterintuitive scientific ideas? So we looked at that in the follow-up study, where we gave 142 children in our age range a science tutorial, and we assessed their understanding of the topics that were covered by this tutorial before and after in relation to their CRT-D scores. So this was a pre-post design. At pretest, the assessment we used was a statement verification task. Children saw statements about living things. So again, we used our vitalist biology as one of our domains, or they saw statements about matter, material kinds. So that was another domain we brought in. Matter is a counterintuitive domain because we intuitively associate matter with things we can see and touch, as opposed to, say, atomic structure. So something like air is material, even though we can't see it or touch it. So then we gave children a little science tutorial, a 7-minute instructional video, and they got a tutorial either about life or about matter, not both. There's some attention checks. All the kids passed those. So they moved on to the post-test, where they got 96 additional statements about life and matter. And they were closely matched with our pre-test because the statements had the same predicates, but we changed the subjects of those predicates. So let me give you some examples of our assessment items. We had two kinds of statements that kids verified. Some of the statements were intuitive, so they were our control statements. Things like bricks take up space, which is scientifically true, but also intuitively true. Or dreams take up space, which is scientifically false and intuitively false. And then our experimental stimuli were counterintuitive, where science and intuition disagreed about the truth value. So those were things like air takes up space. Scientifically, that's true. Intuitively, that's false. Air just seems like empty space. And rainbows take up space, which is scientifically false, but intuitively true. A rainbow's just light. All right, so before I show you the relationship between those data and the CRT-D, let me first just show you that our tutorials worked at improving children's science understanding for the counterintuitive content. So here we have the proportion of statements they correctly verified at pretest and at post-test. And the top line are the intuitive statements where we expected them to answer those correctly from the start, and they did. And then below the bottom line is the counterintuitive statements like air takes up space. And here we're just looking at data within the domain of instruction. So, just looking at cases like matter statements, if you got the matter tutorial. And you can see that the accuracy for these kinds of statements improved following our tutorial. So we closed the gap between the two kinds of statements. All right, now let's look at accuracy in relation to CRT-D scores, which are on the x-axis here. So the scale goes from 0 to 9. Nobody actually answered all 9 right, so we go up to 8. And then on the y-axis, it's the proportion of statements correct at pretest and post-test, all the statements, intuitive and counterintuitive together. So the first thing you'll notice is that the lines are moving up. At both assessment periods, cognitive reflection scores predicted science understanding on our tasks. But the more interesting finding is that you'll also see that the lines are pulling apart as you move from left to right, indicating that children with higher CRT-D scores show greater improvement from pretest to post-test. Even though they started out with higher scores, they also improved more following the tutorial. So I don't have time to tell you about some other things that we've been doing with the CRT-D, but we found that it predicts a lot of different forms of reasoning. So CRT-D scores predicts children's ability to differentiate events that violate physical laws and are impossible from those that are merely improbable. It predicts their ability to differentiate actions that violate moral rules from those that are merely unconventional. It predicts their ability to determine whether two variables are related to each other given covariation data. It predicts their ability to detect fake news and differentiate it from real news. It predicts their evidential reasoning, so the extent to which they prefer statistics over anecdotes. It predicts arithmetic reasoning, specifically their ability to employ the order of operations when solving equations. And then it also is a predictor of number sense generally across lots of different math tests. All right, so then I will move to the last part of the talk, where I'll tell you about our most recent data, where we're looking at trying to improve children's cognitive reflection scores. So there hasn't been a lot of research on improving cognitive reflection in adults, because cognitive reflection tends to be treated as an individual difference variable. But there has been some research where the cognitive reflection itself is the variable that's the outcome rather than just a predictor. So those studies have found that instruction on cognitive reflection tends to have weak effects or circumscribed effects, where they apply to other questions of the same type, but they don't transfer to other kinds of brain teasers. So for instance, here's some data from a study by Isler and UMass, where they administered a variety of interventions, more than they're just listed here. The blue bars show you the number of problems answered correctly out of 5, and the dashed line is baseline performance where there was no intervention. And so you can see for the bottom 4, these interventions had no effect on adults' cognitive reflection scores. Enforcing a time delay didn't lead to better responding, and asking them to do various kinds of reasoning didn't lead to better responding. They did find small but significant improvements when people were asked to justify their judgments or given monetary incentives the more questions they answered correctly. The biggest effects were found for debiasing, but I don't think these are great effects because they are item specific. So basically, they talked them through the bat and the ball problem about how to do that problem, and then gave them alternative versions of that bat and ball problem, and they scored better on those. So we wanted to adopt an approach that was that extended beyond specific kinds of items, that potentially was transferable. So we thought about what's required to respond to a brain teaser correctly. Well, one thing that's required is that you have to inhibit whatever intuitive response pops into mind. And something else that's required is that you have to search for a more accurate alternative. So accordingly, we developed 2 kinds of tutorials where we encourage children to stop and consider information relevant to each of these obstacles. So consider why their gut response might be wrong. So we call this kind of training the why not training. Why might your answer not be correct? Or consider what alternatives might be correct. What else might be a possible answer to this question? So we administered this training in the context of zoomed in photographs like this one here, where children had to guess what it was. And we gave them options. So the options are cinnamon, rope, and wood. So you all pick what you think it is. And the answer is cinnamon. So this is the regular photo, and it's zoomed in at the top of one of those. So we did some pre-testing with these photos with adults, and we picked photos where we knew most adults would pick the wrong answer. So most people pick rope in that case rather than cinnamon. So children saw 6 of these zoomed in photos, and they made a choice as to what they thought it was. And then before we revealed the correct answer, they were encouraged to generate reasons why their guess might be wrong if they were in the why not condition, or reasons why the other options they did not select could be right if they were in the what else condition. So again, this was a pre-post design. So at pre-test, they got 5 CRT-D items. Our original battery had 9 items. We just added 1 more to create 10 and then break them up into 2 groups of 5. We also measured children's executive function because we wanted to see if scores on the CRT-D improved. Was that a selective effect, or did just information processing skills improve in general after the interventions? And our tutorials encourage children to stop and consider either why not or what else. And they were followed up with 5 new CRT-D items and the same executive function tasks. So by happenstance, our items, we had 2 items in the CRT-D that had the same trick that would lead you astray and prompt the wrong intuition. So 2 of the items relied on an interfering semantic association. 2 of the items relied on prompting subtraction when in fact subtraction was not necessary. And we filled that out with the extra item. So given that we had designed the test like this, not intentionally, we were able to create 2 subtests, subtest A and subtest B, that were matched in content. So our participants were 222 children recruited from public playgrounds, and our CRT-D blocks were counterbalanced across kids. So a block that served as a pretest for half of the kids served as a post-test for the other half, and vice versa. All right, so we found that our trainings did work. They had weak effects, unfortunately, but they were reliable effects. So in the white bars here, this is their pretest score out of 5, and then the gray bar showed the post-test score. It looks like children improved given the what else training to a greater degree than the why not training, but statistically these 2 differences are not themselves different. So there's a general improvement across both of the trainings. The effects are much larger if you only look at kids who answer fewer than half of the CRT-D items correct at pretest, but then you run into problems with regression to the mean. So even with the full sample, where some of these kids are doing quite well at the start, you see reliable improvements. And in fact, you see improvements across the majority of the items. So it wasn't the case that it was just like 1 or 2 items where kids were better after getting the training. For most of the items, if you got that item at post-test, you responded more accurately than if you had gotten the same item at pre-test. Well, you wouldn't have gotten the same item. A different group of kids would have gotten that item at pre-test. In terms of executive function, we found that the scores across our 3 measures were comparable from pretest to post-test. So inhibitory control did not change. Cognitive flexibility did not change. We did see a small boost in working memory, though. So one thing that we did then was look at the gains from pretest to post-test for our CRT-D scores. Did they remain significant even when we control for gains in our executive function scores? And they did. Something else we noted, though, is that how well you scored on the CRT-D at post-test was predicted by your executive functioning scores at pretest. When we control for age and pretest CRT-D scores, because of course the post-test CRT kids who scored well on the CRT-D at pretest also scored highly on post-test. So controlling for that variance, executive function seems to have predicted some of our changes in CRT-D. So together, these findings imply that cognitive reflection is distinct from executive function, but they're related in that kids with higher executive function scores coming into the experiment seem to learn more from our cognitive reflection tutorial. Okay, so let me wrap up with some general conclusions. Children's skill at reflecting before responding, that's another way of thinking about cognitive reflection. It predicts many other skills, including rational judgment and decision-making, endorsement of normative thinking dispositions, conceptual understanding of math and science, propensity to learn science as well. And it looks like this skill can be facilitated by encouraging children to reconsider gut responses or overlooked alternatives, or maybe both. So let me return to some of the implications that I started out with, why I think it's important to study cognitive reflection developmentally. So in terms of methodology, we found that the CRT-D is often a stronger predictor of the outcome variables of interest than the executive function task, but it's also much easier to administer. So it's faster and easier to administer. So just to give you a sense of that, for most of our studies where executive function was involved, the majority of the study session was taken up with the EF tasks, which we weren't even actually that interested in. So using the NIH toolbox to measure the inhibitory control with the flanker task, that involves 4 practice trials and 20 test trials. To measure cognitive flexibility with the dimensional change card sort task, that involves 4 practice trials and 40 test trials. And then, of course, to use the NIH toolbox, you have to pay $500 a year. And our CRT-D items are free. But more importantly, I think these data have some theoretical implications, which is that thinking about your thinking may be a prerequisite for the development of various forms of higher order cognition, rational judgment and conceptual change being 2 of those. There's this open question, though, as to why. Like, what exactly is cognitive reflection? What is the CRT-D measuring? And I don't think it's measuring one thing. I think it's measuring a suite of things that are all important. So one thing it's measuring is perhaps a tendency to stop and think and be reflective about the answer you're about to give. It's also potentially measuring executive function at a higher level, because in order to answer a brain teaser right, you have to inhibit the wrong answer, the gut response. You have to be flexible in seeking out alternative responses, and you have to retain the responses you're considering and the original prompt in working memory. But you have to do this on your own. There isn't an experimenter guiding you through the process or cueing you to do these things. So it's sort of the coordination and the self-directed coordination of EF skills that might be essential. There might also be a motivational component to performing well. Some children just might be more motivated to answer correctly, and others are okay giving the wrong response. And it's possible that all of these things together are important. And then finally, in terms of educational implications, it looks that like our more cognitively reflective children are better equipped to learn counterintuitive ideas in science and in other domains such as math. So if we could spur cognitive reflection, boost cognitive reflection, that might improve other forms of reasoning and have downstream consequences. I'm not sure if the techniques that we used are the best approach. They had a small effect. I'm not sure how reliable those effects would be moving forward. But we also only saw the kids for a total of 20 minutes. So presumably an intervention where you consistently reinforce the habit of thinking before responding might have long-term consequences of the right sort. Okay, so let me acknowledge the James S. McDonald Foundation for funding this research, my collaborator, Andrew Young, who's collaborated on all this research, and Tia Gong, who spearheaded the project in China. And because I work at a liberal arts college, all the research I do is in collaboration with undergraduates. So here are some of the undergraduates that collected and analyzed these data. All right, so I'll stop there and open the floor to questions. Yes.
I'll just say again, that was awesome. Thank you. So I'm curious, obviously CRT is like one of those things that seems to go with all good things. And so I'm curious if low CRT is good for anything. I'm thinking maybe happiness or sense of humor. Like, are there advantages at all? And that seems to maybe pull out some of the theory about what it is.
But why was happiness your first suggestion? Here's a group of high CRT individuals. Are we all miserable? No.
I'm a happiness researcher. So.
Yeah, I mean, in the adult literature, CRT definitely correlates with some interesting things, like people who are higher in CRT are also are less likely to endorse common beliefs about, they're less romantic. They don't have a traditional view of romance. They're more practical in terms of how they view romance. And what else? It seems like high CRT isn't necessarily it correlates with intelligence, but it's not the same. It's not. It's just like if you're smarter, you also are cognitively reflective. It's more of just a way of processing information. I don't know if like encouraging children to be more cognitively reflective would then also make them less romantic. I think it's probably a useful skill to have definitely in an academic context, presumably in just an information processing context when it comes to like being a literate citizen of the world. Yeah, I'm not sure like that there's any reason why we would want to be content with people not being reflective.
Right, or I'm just thinking more like if you happen, given how hard CRT seems to be to change, right? Like you can change it a little bit. If you happen to be working with a kid who's low on it, like where's their superpower, I guess. So anyway, just maybe a thought question.
Right. Yeah. I mean, it's one of many skills. So like, if science, if you're a science educator, the primary focus should be on imparting science knowledge. Then the reflection part is presumably helpful in keeping your intuitive ideas straight from your scientific ones. But if you don't have the knowledge in the first place, like that reflective component's not going to be helpful.
Oh, yeah.
Thank you. This kind of relates to Liz's question, I think. But I guess I'm wondering how much, by the time you're an adult, you've learned a bunch of stuff that presumably impacts how cognitively reflective you are. And I expect that that's true of children as well. And I expect, you're talking about curricula that might promote these sorts of think before you answer, et cetera, et cetera. Some of that is probably already built in. And I'm wondering to what extent you think any of that has already ended up influencing the children that you're testing. So have you looked at like children, did you look at SES differences in these kids? Did you look at, I know you looked at other scores in terms of cognitive stuff, but I can imagine a kid who's in a school district might have been encouraged along their first science or all curricula to stop before they think. And I guess that means, could you just like randomly survey teachers talking to their students and how much of that did they naturally do and whether that impacts kids responding, or look at sort of kids from different schools, do they tend to huddle together in terms of their average reflection scores in a way that is independent of SES, stuff like that.
Yeah. So like another way of putting your question is that first graph I showed where the cognitive reflection scores were increasing with age, that might actually be driven by education, right? Like if you took a 4-year-old and kept them out of school, then maybe they would stay at like CRT-D of 1 or 2. Another component to this is just familiarity with the specific brain teaser. I mean, it looks like with adults that actually does drive a lot of the effects because they've seen that specific problem before in their math class, or they've seen problems like it, and so they know that the first response that came to mind is wrong, and they're retrieving a memory of how to do it correctly, as opposed to like deriving the correct answer in the moment for the very first time. Yeah. Right. Yeah. So I don't think that the fact that familiarity with the problems takes away from the significance of reflection as like something valuable to study and possibly improve. I think that there's no way that you could teach someone to be reflective without problems that had content, right? And so Right. 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 Yeah. I mean, one thing that has been kind of puzzling that I'd like to explore more is children's own awareness of the fact that they are answering brain teasers. We frame them as brain teasers. We don't hide it. We say our first game today is brain teasers. But if you watch children perform the task, it feels like some of them think that there's easy, straightforward questions intermixed with brain teasers. So they'll be like, cows, oh wait, they drink water. And then for the race, they're like, first place, that one's easy. Let's keep going. Like, it's not like they're like, here's another brain teaser. How have I gotten it wrong? I think I got that one. So like, sort of the mindset you have to be in to activate reflection seems to be interestingly different among children as well. And I think there's going to be some interesting interactions there between the content and then just general mindsets that you have to activate. We haven't teased those things apart.
Thanks for a great talk, Andrew. Can you hear me?
Mm-hmm.
I want to ask you about motivated reasoning. So in many of the examples you gave, all the data, the outcome is not something that people have a stake in, like how many lily pads, etc. But what if you're reasoning about something where the conclusion matters to you deeply? Could be part of your entity, or it could be some part of your moral world. Mm-hmm. So what about another perspective to all this, which is that reflection is not so much about finding out the truth or correcting error, but it's really it's like a lawyer who's trying to defend a certain position that's already held.
Yeah. I'm not at all confident that a cognitively reflective child would be vigilant against fallacious conclusions that they want to believe in, just like it doesn't seem to be protective for adults. I mean, at least not in terms of like, say, a CRT-D score. I think the CRT-D score is a measure of something broader that maybe people who consistently value reflection and a sound evidential basis to what they accept, they would be resistant to accepting the claims that they just want to believe are true. So, yeah.
Would they be less prone to something like a confirmation bias, where the conclusion is something that they care about?
Mm-hmm.
So maybe everyone's prone to these kinds of motivated reasoning, but are people who are more reflective less prone? Or isn't that because you have two independent effects?
I think they're less prone, but not substantially less prone. I'm having trouble thinking of a specific study to cite. Certainly, like the only work that's been done on cognitive reflection is like in children is what we've done, but it's a large adult literature, and I don't know the ins and outs of it. Yeah, my guess is that in that kind of paradigm, you would see a main effect of motivated reasoning across everyone, but then it would get a little bit weaker for people who are cognitively reflective.
I'm wondering if the CRT-D is just a working memory trait or ability test. By that I mean, you're essentially asking people to stop. Don't trust your gut or intuitions. Think otherwise. What are the other alternatives? These are all different bits of information that need to be handled in working memory.
Mm-hmm.
And in your training, you also show that the working memory performance improved after your training, right?
Mm-hmm.
So what if we're just giving people or children working memory training? Teach them to hold more information in mind as they think through problems.
Mm-hmm.
Will that actually increase CRT-D scores, or what's the relationship between CRT-D and working memory?
Well, I think working memory is a prerequisite to answering CRT-D questions correctly, but it's not sufficient by itself. So I don't think a working memory training would then transfer to higher CRT-D scores. We were surprised to see that working memory scores increase, but on our own reflection, we realized that was the only task where stopping and thinking would actually help you and not hurt you, because that was a task where you're trying to remember a number and repeat it backwards. So stopping to make sure you've encoded the number and then working slowly through the number would be helpful for accuracy. Whereas stopping and thinking would only hurt you when you're trying to name as many animals as you can in a minute. or one of the inhibitory control measure was we're actually measuring speed with which you could make make a response that worked against a prepotent association. So I'd have to look at this with a variety of measures. I'm not too certain that our training was actually helpful to working memory in general. It might have been helpful for our one task of working memory.
I'm curious about what you said about thinking as a habit and sort of developing this in kids, because it seemed counterintuitive to me, where we might often think about thinking as something where I'm going to sit down and I'm going to now think about this problem. Whereas the idea of thinking as a habit sort of opens up this possibility that it can be more spontaneously deployed and so on. So I'm wondering whether we're actually dealing with different kinds of thinking here, where there might be more spontaneous reflection, which actually which might be different from cognitive reflection that's triggered by problem. And so the first question is whether you think those two go hand in hand, like spontaneous reflection versus more deliberate reflection. And then in which case, like, I'm wondering whether, yeah, the more spontaneous reflection might kind of feed to what Liz was saying about it making you happier, as opposed to more deliberate reflection being the one that might lead to different outcomes.
Yeah, I mean, let me show you the items again, because we found this weird unintended item difference. So given a pair where the trick is the same, kids tend to be better on one of the two items. So for instance, the one where the trick is that it evokes a list, a memorized list, like eeny, meeny, miny, mo, or Monday, Tuesday, Wednesday. Kids answer the eeny, meeny, mo one correct more often, meaning they don't fall for mo, than the second one, that is, they say Wednesday rather than Emily. So it implies like Monday, Tuesday, Wednesday is a more rehearsed list, and you're more likely to just follow along with your intuition, so that spontaneous reflection doesn't arise in the way that it's more likely to arise for the eeny, meeny, miny, mo one, because even though kids know that rhyme, it doesn't have the same pull on their responses. So I think the degree to which you engage in reflection is definitely going to vary with the strength of the intuition. And even for people who are very reflective as a general mindset, if the response that comes into mind feels very correct, you probably won't reflect.
Yeah, and so in which case it feels to me like maybe encouraging the more deliberate reflection might actually be really tricky if it's so content-based or reliant on the intuitions, as opposed to engaging more or encouraging more spontaneous reflection, where it's like regardless of the content. I don't know, like that, right? Like walking around the world and then being curious. Maybe that's a better route in terms of leading to training outcomes. I don't know. Like, are we? Yeah.
Yeah, possibly. I don't know how curious the average person really is, though. We're all busy. We all have things to do. Even children have things that they want to be doing, and our CRT-D is probably not one of them. I mean, kids actually have fun doing this, but a lot of the other tasks that we do, they would prefer to finish so they can go back to the playground. And so, yeah, trying to encourage them to just be curious about whether or not bricks take up space might be a harder sell than like more specific instructions focused on considering a response. I don't know.
My interests are curriculum and pedagogy themselves. So that's kind of the context to this question. So in terms of educational implications, how would a teacher differentiate between an educational intervention that improves cognitive reflection and leads to healthy and adaptive cognitive reflection as seen by the correlates here, and option B, which could perhaps be a tendency towards self-doubt and obsessive thinking? And the context for that question is I encountered a teacher in my own life who used a form of cognitive reflection to help us assess all of the math problems that we had completed. And so as an adult now, I like what that has done because I complete whatever it is and I'm able to do like a good self-check. And I like that because obviously it's adaptive and it has good consequences. But what I did notice in myself at a younger age is I had to get over the idea of, because I'm checking it over, it must mean that I am wrong. And then that had well-being consequences. So obviously I will acknowledge my bias as someone who is neurologically prone to more anxious thinking, but it's just something, that's what I immediately thought of here.
Yeah, maybe that goes back to the first question about, are there benefits to low cognitive reflection? Perhaps it's being less anxious. Because, situations that mirror the brain teasers that we have, they're analogous. They don't come prepackaged as such. We have to decide that there's multiple options, multiple decisions we can make, multiple solutions we could adopt. And the one that we have adopted is suboptimal or not as accurate. So, if we were always second guessing ourselves, not only would that just be slow and inefficient, to function in the world, but it probably would give rise to anxiety. So yeah, and also that kind of addresses your question too. Maybe we don't want to be constantly walking around in the state of curiosity and reflectiveness. Sometimes we just have to get things done. It's an interesting balance. I actually haven't thought much about that. I should end our little training session with a disclaimer.
Janet is next. Okay. Then you would your hand up right.
I just had a question for something that it brought up for me was thinking about impulsivity because of the nature of your first intuition being really important. So I was curious if you read about how variability and impulsivity as a trait affects cognitive reflection, and if that would maybe also mean that interventions for impulsivity might be one way to improve cognitive reflection.
I don't know about the relationship between the two. It's possible that's been explored with adults and I'm unaware of it. It feels like cognitive reflection might be a specific kind of impulsivity that's got, intellectual, conceptual content to it that's not quite the same as being drawn to, say, a specific food or a specific behavior. But I'm sure that there's, it's like cognitive reflection and intelligence are very strongly correlated. But even when you control for intelligence, cognitive reflection still predicts lots of things above and beyond intelligence. I assume there's a similar kind of relationship with impulsivity, that they're related, but cognitive reflection is also tapping into something that standard measures of impulsivity don't.
Thank you. Hopefully you can hear me. Yeah, very interesting talk. And as somebody who looks a lot at cognitive effort, in undergraduates and looks at people's, what drive people's preferences for deploying a lot of versus a little effort. What I was curious about is when it comes to cognitive reflection, building off this recent discussion we just had, to what extent is that capturing kind of children's preferences or willingness to approach cognitive effort as being pleasant versus not in everyday environments? I know some of the questions on the need for cognition scale that you mentioned get very directly at this, but I guess what I would say is to what extent are you able to capture whether these people are really enjoying the task, that they are appreciating the cognitive effort demands, and to what extent does that map onto cognitive reflection? Does higher cognitive reflection map on to just general higher enjoyment of cognitive effort demands, or could there be a dissociation between the two?
Yeah, there's this interesting study with adults that was done out of methodological concerns that the CRT was being thrown on every study being given to NTurkers and other online research participants. And the concern was that it doesn't actually measure reflection anymore because by being exposed to the CRT, they now know what the right answer is. And it turns out there's no relationship between how many times you had seen the CRT and whether you responded accurately, which is kind of shocking. There are people who had seen it dozens of times. They might never have been told what the right answer was, but they also weren't curious enough to seek it out, right? So those people presumably did not derive pleasure from doing it, and they they weren't curious enough to want to know more, whereas other people are. And again, maybe in the adult literature, people have looked at this relationship between sort of the affective components of brain teasers and your performance on it. But I think that is an interest. I think that there's that last possibility I mentioned as to why cognitive reflection matters, desire to answer correctly. I think that's non-trivial. I think that that's sort of a baseline requirement that you actually want to answer the brain teasers correctly before you then stop and think, and before you think about certain particular things.
Yeah, I'm really interested in this, and some of the other discussion has got me thinking a bit about stereotype threat, and I'm just wondering, like for maybe not for the CRT-D, but for your other tasks, if it's very clearly like, oh, we're testing your scientific or your math abilities, did you account for that in your protocols to make sure that, people that were identified as female or, come from Black communities who are stereotyped as being worse at those things, were they allowed the chance to perform just as well, I guess, as other folks? And do you think that those stereotype threat could maybe account for any differences in the CRT-D scores?
Well, one sort of positive finding from our CRT-D research is that there's no gender effect. So girls perform just as well as boys, and that's not true for the CRT. That there's strong gender effects that men tend to outperform women. And it probably goes back to the math content. It might also, stereotype threat might be a part of that. One thing that your question, a concern it raises in my own mind, is that we always administer the CRT-D first before we do anything else. And it might actually be priming certain ideas about, what a good test subject is like. The kind of person who can answer brain teasers might, be the kind of person where we think it's going to get a gold star on the remaining tasks. The kind of stereotypes that might be activated, I think, would be indirect by the content of our questions. But in the adult literature, sometimes people use the cognitive reflection test to prime analytic thought. And it works, but also I'm not sure why it works, because most people get them wrong anyway.
We have time for one more question, as long as it's not too intellectually deep. Any volunteers? Here. Yeah. Go through this and maybe we'll time as well.
I was curious whether cognitive reflection is necessarily verbal, or if you could measure the same thing in some other way.
It feels pretty verbal. Like a behavioral test would feel like it would be closer to impulsivity. But do you have a reason for wanting a nonverbal version? Or?
No, I wasn't going somewhere specific with that. I was just curious about, could it work for nonverbal kids, or could there be an animal analog of this? Yeah, but I don't have a correct answer I'm leading towards.
Oh, animal. Yeah, I can imagine some kind of puzzle box where there's like the obvious thing to do, but it's not the right thing to do, or not the optimal thing to do, and there's something else you need to do instead. Although, as you get further away from the original test item, it feels more like something that would be predicted by cognitive reflection as opposed to a measure of cognitive reflection.
Okay, I have a really quick question. I haven't been very familiar with developmental research with kids, but I was kind of curious, is it a standard to kind of recruit at playgrounds, and whether or not that was a feasibility thing? Or if there's pros and cons to the sampling, demographics and stuff like that?
Yeah, we do that out of necessity for being at a small liberal arts college where we can't bring kids into the lab, at least not in large numbers. There's no middleman that you have to pass through to get access to children at the park, other than their parents. But there's not a teacher and a principal and a superintendent that all have to look over a study. So we found it a very productive way of testing kids, as long as you're not too picky about ages. We can test a wide range of ages. But if we were focused on just 4-year-olds, it would take us a really long time to get that particular sample to the right number.
So I was told that the classroom that has to come in right after this, so we need to break it this time.